that anonymity means that these two sound waves are actually overlapping onto each other. Those two sound waves should meet over at a certain point, and that is the first thing that you have to have, whether you want to have maximum or minimum whatsoever. And then you have to specify what you should expect to get as zero. Zero means minima. So to get minima, the phase difference between the two sound waves should be 180 degree, or you can write pi by 2 radian, pi radian, or you can write that they should meet in exactly out of phase. You can write in that order. So number A is actually pretty simple to answer. It's a 2-mark question. You can pretty well easily answer that number 2. A is not a big deal. Problem happens for number B. How can you take a bite for this question? Did you do any progress? If you did, share that. You can share that with me. I would like to hear about that. And did you do any calculation about this math?
Path difference find করতে হবে.
কোনটা?
Path difference.
Path difference. Good, beautiful step. Yeah, we are definitely gonna need that. So path difference কত আসছে?
28.06 or 28.
So, for those of you who are trying to understand, one sound wave is going to come from here, and the sound wave is going to travel from here through here. So this is the path of sound for one wave, and this is the another wave. So if we can find out the individual lengths, actually one is already given. We just have to find out how much is this hypotenuse, because this is actually a right angle triangle. And if we do the subtraction, we can find the path difference. So let's find out the path difference. So in this case. Path difference equals to root over of 100 square minus plus 80 squared minus 100. এটা কত হয় দেখো তো? 28.0 না?
06 with a 1 in sir.
28.06.
Yes, sir.
So you can write it as 28.1 centimeter if you want to do the math in 3SF, which I usually recommend. But just because the mark scheme is given in 28 and all the 2SF values, so I am preferring to give for this question in 28 centimeter, just to keep things simple. Or I can actually write it as 28.1 centimeter as well. That also would not matter because we're going to use this information anyway. So that's the path difference. Now, we need to find this out. That goes without saying. The question here that tells us that the speed of the sound in air is 330 meters per second. The frequency of sound from S1 and S2 is increased. Determine the number of minima that will be detected at M as the frequency is increased from 1 kilohertz to 4 kilohertz. First of all, what I need you to understand, as per the question, the question says that, have a look at this sentence. I told you that we to make sense of this sentence. As the frequency of S1 and S2 is gradually increased, the microphone M detects maxima and minima of intensity of sound, which means we're going to keep the sources in their original position. We're not going to move them. We're going to keep holding the microphone exactly at this position as well. We're not going to move it. What we're going to do, we're going to change the frequency by which both of these sound sources are vibrated by. And that will cause multiple maximas and minimas to be detected by this M. So we're not moving the microphone, but it will detect alternately maxima and minima, which means the pattern itself, or that fringe pattern itself, is going to pass through that point. Now, this is the first thing that I want all of you to visualize very clearly, which I'm going to try to show you over here. Let me get a bit bigger canvas. So what I want you to remember, that whenever we have the double fringe slit separation scenario, let's say this is the double slit, these are the two slits that we have, and here is the screen, and this is the central maxima line. So the formula that relates all of these variables is given by lambda equals to AX by D. This is what we have learned from earlier cases. Now take a good look at this point. If we increase the frequency of a certain sound wave or certain wave, the lambda is going to go down. keeping A, which means a fringe slit separation, and D constant. So if we keep these two variables constant, then lambda and x, they will be directly proportional because they are the only variables left in the equation. They're existing on the opposite sides of the equals to sign, which means in this scenario we're going to get lambda is proportional to x. This is very interesting. This means whenever lambda is going to go down, the x is also going to go down. Now, what does this mean for a pattern where the x is going to go down or x is going to become decreased? This would mean that the entire pattern of bright and dark is going to start squashing. So other than trying to copy a figure, actually I can actually draw a bright and dark fringe. I can try. Let's say I can draw one rectangle over here to work as my dark fringe, and the one over here. Need to move it a little bit up. This should work. Okay, let's say this is my these two are my bright and the dark fringes. So this is let me fill this up, and I'm gonna copy it and copy paste this continuously. So might as well erase this. I'm not gonna need that. I'm first trying to make sense to you the key information of the question so that you can actually understand what is about to happen for the later part, because you first need to understand that why this thing is going to experience multiple maximas and minimas. That's very important, really, really important. So one over here, one over here, one over here, one over here, one over there, there. There. So since this is not properly placed, so I'm going to select this whole thing and move it a little bit. So let's say, okay, let's say this is the scenario. So what I want you to understand that whenever we have this scenario, I'm now showing you as bright and dark because this is easier to draw. But for sound, we're gonna get loud sounds and quiet sounds. So loud sounds are defined as the maximas and the quiet sounds are defined as the minimas. So, and the detector is gonna be not gonna be a screen. We have to use a microphone that should be held in multiple places along a vertical straight line, or in this experiment, we're holding it in a single place. Now, try to understand. If we start to reduce the wavelength of the incoming sources and keep the microphone at a single position, the fringe separation X is going to become smaller, which means earlier, let's say the actual pattern of the wave was like this. Whenever we're going to start reducing the lambda, this whole thing is going to start becoming squashed from both sides in such a way that the central maxima would still remain a central maxima, but the entire pattern of bright and dark fringes will become smaller because the X is becoming smaller. This is the part that I want you to visualize. So what I want you to understand, if we did in this case, consider all the black parts as silences and all the white parts as loud sounds. If we did hold, the reason I'm not drawing this overlapping because this would be very difficult for you to understand. That's why I'm showing this in two different parts, but they are not going to happen like that. This will convert into this one. So they are not simultaneously present. They are alternately present. I need you to remember that. What was I about to draw? Okay, let's say if we hold up a microphone right over here, let's say, let me draw that with a different color, maybe red. If we hold up a microphone over here, let's say at this position of the microphone, it was detecting a maxima. Count which number maxima is this? This is central maxima, 0, first maxima, second maxima. If you start increasing the frequency or reducing the wavelength, the X is going to go down. And if we still keep on holding the microphone right at the exact same position, what is this going to experience? Have a look. For this pattern, this is my 0, this is my 1, this is my 2, this is my 3. So if we keep holding the microphone exactly in this physical location, we're not going to move the microphone physically, but we're going to change the sources that is producing the sound over here. So the pattern is going to become squashed. So if we keep on holding this thing is going to experience the passing of this dark fringe / silence and the entry of this third maxima onto this one. So just for my drawing over here, trying to make sense with you, that whenever the lambda is going to become reduced because frequency has been increased, this microphone will experience silence, minima, and then another maxima because another white space has showed up in this place. If we keep on decreasing the lambda even further, this whole pattern is going to squash even more, which means more maximas and minimas will pass through this physical location because the entire pattern is going to become more and more squashed. In this case, in this example, have a look. We have increased the frequency of the sound source from 1 kilohertz to 4 kilohertz. That's about 4 times increase in frequency. So the lambda will also become 4 times as small. So if you logically think about it, if the lambda is made to become 4 times as small, which means the fringe separation will also become 4 times as small compared to the first case. So whatever the fringe separation that you get for 1 kilohertz, you're gonna get about 4 times smaller fringe separation for 4 kilohertz. So the entire pattern is getting squashed. That's why multiple maximas and minimas are gonna pass through this thing. The central maxima will hold its position because central maxima is a central maxima, which is a symmetry point. But the entire pattern is gonna start squashing onto that, towards that location. এই আইডিয়াটা বুঝা গেছে কিনা?
Yes, sir.
Any questions so far? I just explained what this sentence essentially mean, that why it would be detecting this task. Achha, if we did understand what is happening over here, the rest of the part is actually pretty simple because the rest of the part is simply follow a couple of things. Achha, one of the problem for this question is that, one of the additional problem of this question is that, first of all, it is difficult for many kids to understand the content of the question, the part that I just explained to you. I mean, if the students are not introduced to this kind of questions beforehand, if they are coming across this question in the first place, it is pretty common that the students cannot even comprehend that why a single location of microphone would experience multiple different parts of maximas and minimas. That's the first difficulty that the students face, which I tried to explain to you, and you agree that you understood. That's point one. The second information is that in many cases, to solve this problem, the question is asking us that determine the number of minima that will be detected at M as the frequency is increased from 1 kilohertz to 4 kilohertz. That's what they're asking us. The problem is that there is not a single direct formula by which you can find this number. For example, if you consider the equation lambda equals to x by d, if you know any of the 3 variables and you are asked to calculate the fourth, you place all the variable values in the equation with appropriate units, you can calculate the fourth variable. So that's pretty simple. But there is not a single formula that can actually give you this thing, the number of minima that will be detected at M. You have to find this by trial and error. Now, what does the trial and error essentially imply? What does that actually mean? Let's have a look at this one. So I'm going to try to do multiple steps of calculation over here to make sense with you. The reason I'm showing this to you because when I first attempted to solve this problem, I could not. That's the basic truth. When I first attempted to solve this problem on my own, I could not solve it at all. I was very devastated. Can't solve the problem, 4-mark problem. What is this? Then I looked at the mark scheme. The mark scheme didn't make sense. So I tried to have a convenient way to understand and also be able to explain the problem to my students in an understandable way, which I could not do for about nearly 2 years. After 2 years, one of my older student, whose name is I shouldn't have forgotten that name. So one of my students, he actually saw this problem, and I explained them my struggle, and then he came up with an explanation which I'm just explaining to you. So he gave me this explanation, sir, if you go in this way, first explain this part, and then slowly go on with this calculation, it would be easier for the student to perceive. And till date, I'm doing the same thing. So it was a very difficult problem for me, but currently I can still explain this because there are steps that I have made in my head to make this problem work. So let me show you how to work this thing. Whenever, let me find out the lambda for 1 kilohertz. So 1.0 kilohertz. So lambda 1.0 kilohertz would be 330 divided by 1000, which gives you how much? 3.3 centimeter. I'm writing everything in centimeter because I would like to compare everything in centimeter. I just want to do that. Is it 3.3 or 33? 33 now?
0.33.
330 divided by 100, 1000 into 100. 330 divided by 1000 into 100.
33.
It's supposed to be 33, yes. So let me rub that up. Okay, so 33 centimeter is the lambda for that hertz, and then lambda for 4.0 kilohertz. K should be bigger. I mean, the line should be bigger. That should be 330 divided by 4000. This should give you 8.25 centimeter. So this means first our wavelength was 33 centimeter, and as we increase the frequency from 1 kilohertz to 4 kilohertz, the wavelength slowly reduced up to 8.25 centimeter. So because the wavelength is now decreasing, the D should be increasing. Sorry, Dina. The X should be also decreasing. So now we have to find out that exactly for how many of these range values, between these two range values, exactly for which value of lambdas can we satisfy the quotient for how many minimas were found. So because the question is asking us the number of minimas. So you have to find out exactly for which values of lambdas minimas will be available at this point, which means this path difference will actually give us the minima. So let's write up the equation for minima right now. So the equation for double slit experiment minima is that path difference is n plus half lambda. This much should be equals to 28.1 centimeter, or you could only write 28. Actually, if I am writing to 8.25, I might as well write 33.0 because all of these numbers are supposed to be in the same SF. You should not mix up SFs in a single question. So that's why writing a 0.0 over here is actually pretty important. So I'm writing 28.1, no big deal. So in this case, I'm going to subject lambda because I want to calculate how many, I want to find out how many lambdas can I get for this scenario. So lambda divided by 28.1 divided by n plus half. So this is my expression for the calculating that exactly what values of lambdas would give me minima at this microphone position. So now I'm going to start placing different values of n, and I'm going to try to calculate the lambda values. So I'm going to show you this over here. Let's say whenever n equals to 0, we get lambda equals to 56.2. When n equals to 1, kids help me. 28.1 divided by 1.5. How much do you get? 18.73. 18 point, and then whenever you place n equals to 2, 28.1 divided by 2.5, 11.24. Actually, 3SF values, we can actually stick to 3SF values. I'm going to write centimeter behind all of them, so don't worry that I am skipping those parts. I'm not. I'm just trying to get to the point when I'm going to step out of this range. You can see it very well. As we are increasing the value of n, the lambda value is slowly becoming smaller, which means our lower acceptable limit should be 8.25. So we're going to keep on going further down the line as long as we do not fall below 8.25. So let's keep on doing this. So n equals to 3. You get 8.03. All right. So I could actually go on further, but I am not going to go any further because I can see it very well in the pattern that as the n value is increasing, the lambda value is slowly decreasing. This value, this last value for n equals to 3 is definitely smaller than 8.25. Being smaller than 8.25 means what? Being smaller than 8.5 means what? It means that this lambda would not give us minima, and it is already smaller than the minimum acceptable range for which we are trying to achieve the math, that is 1 kilohertz to 4 kilohertz. So within this range of lambda, only 2 of the lambda values satisfy the equation for minimas. One of them is 18.7 centimeter, and the one is 11.2 centimeter. বুঝাচ্ছে?
Yes, sir.
So your answer is, that's it. Working the দেখো সবাই. I'm gonna give multiple twists and variations to the same question and ask you to do a different couple of different variant of this question to check your understanding of this problem. So have a very good look. I'll give you 1 or 2 minute time, and if you have any question, you ask me right now.
Sir, n is equal to 1 first maximum জন্য না?
No. If we use the equation n lambda equals to pad difference, this is the generic equation for maximus, where the n value can be replaced as 0, 1, 2, 3, 4, 5, 6, 7, 8. It can go on. This is the defining equation for constructive interference or maxima. This is the defining equation for destructive interference or minima. N equals to 0 and 1, 2, 3. This number replacement is applicable for both the expressions. For the equation, to be honest, if you want to think for in terms of actual value of n, it can go on like that. Whenever the pad difference is 0 lambda, you have maxima. Whenever you have the pad difference of half lambda, you have minima. Whenever the pad difference is 1.0 lambda, you once again have maxima. For 1.5 lambda, you have minima. So if you just tell me that n equals to 1, which means 1 lambda pad difference gives me what? 1 lambda pad difference gives you maxima, which is good because 1 lambda comes from the expression of n lambda. So it's, in my opinion, it is easier to remember the formula differently, and then you can just go for mathematical iteration for replacing the values of n. So n lambda, I mean full lambda pad difference is the deciding factor for maximus, and 1/2 lambda involved, which means n plus half lambda, is the deciding factor for minimus. That, in my opinion, works better and easier to remember, if you ask me. বুঝছো কি বলছি?
জি স্যার।
Good. All right. Apparently, none of you have any questions, so I'm going to start changing this question, and I would like you to attempt the solution for this question, for the changes that I'm about to bring about, and calculate me similar stuffs. For example, for the first thing that I'm going to do, this is the same question, kids. I cannot have it a fraction values of zoom over here, so that's the best view you can get. So on your screen, you should try to zoom in if you need to zoom in. I'm going to make 2 changes. First of all, let's make one change. I'm going to make this 60 centimeter and make this maxima. Solve this question for me.
Sir, phase difference কি সব সময় lambda by 2 বা lambda হবে, আর কোনো ভ্যালু হতে পারে না?
Well, whenever we actually along the screen, এই যে স্ক্রিনের যে পুরো রেঞ্জটা, there are certain locations where the pad differences are in order of n lambda. I mean 0 lambda or 1 lambda, 2 lambda, 3 lambda. Those gives you the constructive interference, fully constructive. I mean A plus A, and that gives you the maximum brightness. And places, there are certain other places where you get the opposite sum, which gives you darkness. For the in-between spaces, you can have other type of merging. For the in-between spaces, for example, somewhere between a maxima and a minima, you do not have fully cancellation. You don't have 100% cancellation. Some parts are making constructive, some parts are making destructive, like the way I showed you for the case of stationary wave. The 2 waves are merging, but they are not always merging to cancel each other's effect. They are sometimes merging to add up together, and sometimes they are also once again merging to subtract from each other. So there would be a difference in their behavior. So if the answer to your question is that in the entire in the entire continuous spectrum of this or of the fringe pattern, we're going to have all sorts of addition for all the different locations. The points that by which we define the structure of this fringe pattern is by the locations of maximas and minimas. Is by the location of maximas and minimas. That's why we highly highlight that in at the maximum position, at the maximum positions, the pad difference would be n lambda. At the minimum positions, the pad difference would be n plus half lambda. These are the terms by which we define the characteristic of that fringe separation or the fringe. But that does not mean that these are the only positions where we are having superposition. Superposition is happening all over the fringe. Those are the detectable points which has repeatable behaviors which we are interested in.
Sir, I was talking about phase difference.
Oh, phase difference is you can replace in place of lambda, you can replace 360 degree. So n lambda is the pad difference for constant interference, or you can write n into 360 degree is the phase difference for constant interference, and other vice versa for the n plus half lambda as well. So locations where you have n plus half into 360 degree phase difference, you're going to have this type of interference. Was that your question? No.
স্যার মানে একটা ওয়েভের পার্টিকেল গুলোর মধ্যে কি শুধু ইদার ল্যামডা বা ল্যামডা বাই 2 ডিফারেন্স হতে পারে, 180 ডিগ্রি ডিফারেন্স হতে পারে বা 360 ডিগ্রি ডিফারেন্স নাকি অন্য কোনো?
একটা প্রোগ্রেসিভ ভাবে পার্টিকেল গুলোর মধ্যে
জি স্যার,
সব ধরনের ফেজ ডিফারেন্স হতে পারে. It depends upon what you want to observe. You can observe two particles which are situated here and here. They shouldn't have 180 phase difference. In a progressive way, if you are interested to observe for whatever reasons that you want to observe, you can observe any amount of phase difference that you want to work with. No big deal. It can have all amount of phase difference depending upon which are the 2 points that you are trying to observe. The reason we highlight so much about 360 degree and 180 degree, because exactly similar phase gives you the full addition, and exactly opposite phase gives you the full subtraction. These are the points that we are interested about. That's why we talk about this point so much. But every other value is also possible.
ওকে স্যার, বুঝেছি, থ্যাংক ইউ।
Sure, no problem. So give this a try. Hello. করতেছো মানে are you attending this?
Yes, sir.
আচ্ছা, আস্তে আস্তে করো. I have made 2 changes. Next I'm going to make 3 changes. Why am I muted? If you kids want to look at the solution that that was given in this one, you can ask me. I can put this one to have for you to have a help for the solution. But because I changed the question, I'm currently having this one. But if you want to have a look at the solution, you can ask for that. I'll switch the view.
Okay.
So can you show the last part only?
Nobody say it was easy. It's such a shame for us to part. Back to the start. What is this? What is this? Crayon. Oh. Any luck?
2 আসে।
So 2 এসেছে।
আসলে
Just to make sure that everyone is on the same ground, other than me doing the whole calculation, I'm going to take values from you kids and write up these numbers over here in red so that we can match up those values. And if any of the values does not match, I'll help you to solve this one. So first, tell me the pad difference that you get for this question. What was the pad difference?
16.6 centimeters.
16.6 or 16.7?
2.7
16.6
6 এর পর কত আসছিল?
16.62 আসে।
আচ্ছা 16.6 তাহলে ঠিক আছে, 16.6 centimeter was the pad difference. Beautiful. And then because we are going for the same because I did not change the speed of the sound or the frequency, so our range was exactly same. But in this case, the equation was supposed to be n lambda is supposed to be equals to 16.6, and you're supposed to find out the value for lambdas by replacing values of 1, 2, 3. You shouldn't be placing 0 over here. because placing 0 does not help for this equation. So we are not going to place 0 over here because we are definitely not trying to detect the central maxima. This is offset from the central maximum position. We can very well see it from the figure. So then you have to find out, place values of n equals to 1, 2, 3, 4 till you fall out of the range of 8.25. If as long as it doesn't become smaller to that, and ultimately you could calculate that 2 of the values fall within the range. Is that correct?
Yes, sir.
Awesome. I'm going to do one more change just to give you a bit more practice. So I'm going to do the next change with dark blue. Here, the frequency is changed from 2 kilohertz. Should I go for 2 kilohertz? Yes, I can. Here the frequency is changed from 2 kilohertz to 5 kilohertz. Speed of the sound in the air 330 meters per second, let it be same. And the new distance over here, let's use that as 50 centimeter. So this blue thing is the second question. And you're still trying to find out the number of minima. So I'll read the question for you to make sure what the information. Currently, this is the setup. The two slit separations are 50 centimeter. M is placed over here. 100 is remaining as 100. I'm not changing that. The speed of the sound is 330 meters per second, which is also all right. We're trying to calculate how many minimas will be detected when the frequency is increased from 2 kilohertz to 5 kilohertz. So I'm changing the range for this one. Attempt this now, right now. আমি হোপফুলি নেক্সট স্যাটারডে বা সানডেতে তোমাদের ওয়ার্কশিট কালেকশন করার ডেট দিব। সো কোনো একদিন রাতে আমি তোমাদের আইদার কালকে রাতে অথবা পরশুদিন রাতে আমি তোমার ডেট পোস্ট করে দিব। আই এম ট্রাইং টু কম্পাইল both the workshop compilation. I mean, for what I mean is that in one of the compilation you're gonna have the waves and I actually made the folders. What is the last chapter that you had in your compilation? Work energy power, right?
Yes, sir.
So yeah, so in one compilation you're going to have elasticity and then waves, and in another compilation you're going to have electricity and atomic physics. So electricity has actually 3 parts: electric field, electricity, and stuff. Waves essentially is compiled in 2 chapters: superposition of waves and basic waves. That's just how I divided them when I was starting to teach the syllabus. But practically the ideas are intertwined. The idea of stationary waves and the double slit or the diffraction grating, they're actually a single combined idea. So although there are 2 different worksheets, I divided them in different parts. They are pretty much in many places they are overlapping. So you're going to have this pretty soon, both of them together. I'm preparing both of them simultaneously. Looking forward to it. এটা সলভ করো, আমি আসতেছি। All right, I'm back. So, para gেছে?
Sir, one আসছে।
Anyone else?
Yes, sir. One আসে।
Okay, I'll take values from you. I'll write up all the values so that everyone else of us can compare their effort. First of all, you tell me the path difference. Path difference কত আসছে?
Sir, 11.8.
11.8. Okay. And then I'm going to take the lambda values. So lambda for 2.0 kilohertz কত আসছে?
Sir, 16.5.
Centimeter. And this one?
Sir, 6.6.
6.6. I need another digit. 3 steps are always good. I think 330 by 5,000. Okay, 6.6 আসে. So might as well write 6.60 just to make it 3SF. All right, so these are the values that we have got. And then the equation was, we're trying to find out minima for this scenario as well. So we're going to write n plus half lambda equals to 11.8. We're going to try to satisfy this equation for different values of n. Ultimately, you got only one value that falls within this range, right?
Yes, sir.
ওটা কত n এর কত জন্য আসছে? What is the value of n for you to get that number? n equals to কত জন্য আসছে? 1 or 2?
1.
Sir, 1.
1 এর জন্য আমাদের lambda value আসছে হচ্ছে কত?
7.8.
7.8.
7.8. Which fell, everything else fell out. So that's basically what we are trying to achieve here. এই পুরো প্রবলেমটার ফুল জিনিসটা বোঝা গেছে কিনা?
Yes.
Sir.
ঠিক আছে? So it's a very unique question. আমি usually স্টুডেন্টদেরকে এটা বোঝানোর সময় এরকম additional কিছু প্র্যাকটিস করাই to instill the idea for how to solve this problem as well. There can be a different way for us to give this question, which might be a bit difficult for you to try. So I'm gonna set one homework. Not gonna give you this one right now. Is that how about you try the exact same question, the original, the very original question. So let's so consider the exact original question from the question paper, and let's everything is same. And if I change the question in this manner, have a look. Determine the change of frequency from 1 kilohertz to what? This is the higher range of frequency is the question mark, so that you can get 3 minimas through that point. So this will be one step more difficult for you to find out. So let's say determine the question, the last sentence would read, determine the change of frequency from 1 kilohertz to a higher frequency for which this position microphone will detect 3 minimas, let's say. So in this case, you are defining that how many times you will need to have the value included, but you're not giving the upper range. So this will be a bit more difficult. You can try to solve this. I really don't hope they will give you this number, but this question itself was in its or core was actually pretty difficult. So if you have a look at the marking for this question, you will have a bit of an idea what the examiners feel like for this question. So this was question number 5. This is the question. Let's have a look at the marking for this one. I believe we should have some.
Homework বলতে আমি একটু বলতে পারবেন?
Change to the question.
Yeah.
What I'm saying that determine the change of frequency from 1 kilohertz to a higher value, so that the microphone detects 3 minimas. So to detect exactly 3 minimas, what should be your upper range of frequency? বুঝে কি বলছে?
Thank you.
Sure. So this was superposition question number 5. Have a look at the mark scheme. So take a look at the mark scheme. The mark scheme actually makes pretty little sense. So for which I have been suffering for so long, but eventually it made sense to me. Path difference between the waves from S1 and S2 is 28 centimeter, which perfectly makes sense. It's Pythagoras formula. I understand. Wavelength changes from 32 centimeter to 8.25 centimeter. That also perfectly makes sense because I could calculate the wavelengths using the speed of the wave 330 and the frequencies. Minimum when lambda equals to 56 centimeter not acceptable, 18.7 acceptable, 11.2 acceptable, 8.0 centimeter acceptable. This is how did they calculate this? This is something that I was really bothered about, and then it was all made sense that there is no way that we can get that number 2 out of any equation. We just have to do it multiple times as long as our answer does not fall out of the boundary. If it falls out of the boundary, then we don't have to do it anymore. Then we have to count how many of those values of lambdas actually satisfy the range that we have available. So that was a basic way. So this is a solution that they have given. Have a look at the examiner's report. The majority of candidates did not appear to understand how to approach this problem, perhaps as a result of a failure to answer part A. Very few even calculated the path difference. You see, most of the students didn't even touch the question. They read the question and left it as is. Some students attempted to calculate the path difference. That's it. That's it. So yeah, that's what I wanted to show you. So that's one difficult problem in my opinion. The rest of the things are actually pretty simple. এখানে further difficult question কি কি আছে আমি একটু দেখি. I'm going to pick up some difficult questions for today's class for which the discussion is warranted in my opinion, that you require that discussion. So this is one of that question. Have a look. This is a diffusion grating and the incident lights are not falling perpendicular to the diffusion grating. So you cannot directly use this formula d sin theta equals to n lambda. Such why the diffusion grating formula d sin theta equals to n lambda should not be used in this situation. The answer is a very simple thing. The incident rays are not falling perpendicularly onto the diffusion grating. That's it. And number C is actually a pretty good one. Number C করার জন্য কি আমাদের এখান থেকে কিছু করা লাগবে? We might as well try to solve this question. Explain what is meant by the diffraction of waves. How do you explain diffraction of waves? You know what that is. But for a 2-mark answer, what do you plan to write here? Kids, everyone.
Bending waves when they cross the boundary.
Hold up. I want you to think of something of a complete answer. Take some time that I'm going to write this much and write that exact expression in the chat window, aimed as everyone. Participate. Because this is one of the advantages that we can take in the online classes, that everyone can give the individual responses and we can go through them. What would you think for a response for this question? Likho, chat window likho. You might be wrong and you are allowed to be wrong. So take faith and express yourself. That's important.
So in context to a general wave ito naki sir.
Yeah, this explanation is expect for empirical explanation for all sorts of waves, mechanical or electromagnetic, it doesn't matter. Wave in general, yes.
স্যার আপনি তো প্রাইভেটলি দেওয়ার কথা নাকি
না
জেনারেল ছাড়া?
commonly দাও so that it's easier for us everyone to see. Okay, Zarif লিখছো হচ্ছে bending of waves when they cross a boundary. Bending of a wave when they cross through a boundary. Okay, spreading would be, I think, a better wave because bending also happens whenever they go from one medium to another medium. That is refraction. Spreading might also be a better word. What I think, I don't know the mercy. I'm going to look into it. So you might as well be more correct than me. So, and then cross a boundary is for that we have diffraction, and also diffraction also happens whenever a certain wave passes through a channel or through a gap. So that might also be required. I'm not sure, but that pops in my head. So if at least so, it is the bending of waves when passing through a gap or around a corner. Faiz Mahmoud Liso, the spreading effect of a wave when it passes through a gap. Okay. More people. There are 3 expressions here. We should expect at least 10 more expressions from in the chat window. বলো হ্যাঁ খাচ্ছি No one? All right. Shomik, change of wave direction as it passes through a gap. Okay, sounds about correct. So let's look at the solution. I'm deciding to move on because it shouldn't take that much time for you to respond to our definition. This is number 3A. Have a look at 3A. When a wave front or wave front is incident on an edge or an obstacle or slit or gap, this whole thing is one mark. Wave bends into geometrical shadows or changes direction or spreads. So yeah, changes direction is also good. Spreads itself is also good, or bends into geometrical shadow or change. Yeah, so pretty much every one of you who are pretty much all of you are correct because we have a lot of options over here. None of your definitions that you gave is not going to score you less than 2 marks. Each of you are going to get 2 marks. Good job. So let's try to solve this one. Light of wavelength 500 nanometer is incident normally on a diffusion grating having 750 lines per millimeter. The diffusion grating formula may be expressed in the form of d sin theta equals to n lambda. Calculate the value of d in meters for this grating. So that's pretty simple. D is given by the unit length divided by divided by what? Divided by the number of divisions. So this should be how much? 1 millimeter divided by 750. So you're going to get some value over here. And then it says that determine the maximum value of n for the light incident normally on the grating. So to calculate this part, we just have to place theta equals to 90 degree. I might as well close this one because I'm not using MS Paint in that format anymore. Here, paste, maximize, and then we can start working. So here we're gonna place all the values. This is 10 to the power minus 3 because this is millimeter divided by 750. So you're gonna get some value over here, place it over here. That's basically it. And for to calculate the maximum value of n, the formula is d sine 90 goes to n lambda. Now you're gonna have to calculate the value of n from this expression, which should be n equals to d by lambda because sine 90 is essentially 1. So এখান থেকে d এর ভ্যালু কত আসে দেখো তো।
স্যার একটু উপরে যাব।
মাইক্রো ন্যানো, ন্যানো হচ্ছে 10 to the minus 9, ঠিক আছে। So I get over here 2.26, which means 2, because we have always have to take the integer number that is available, not mathematical rounding. So এটা হচ্ছে আমাদের n এর value. So it actually খুব simple problem. So you just calculate these two values, you get 4 marks. That there is not much challenge for this question. What I'm interested is about this part. Have a look at this question, everyone. Take a good look at this question. Let me just take this out. Can I take this out? I hope I can take this out. Yes, I can take this out. Let's paste it. All right. No. All right. Have a look at this question number C. Light of wavelengths 590 nanometer and 595 nanometer, two different wavelengths, is now incident normally on the grating. So we are not only sending a monochromatic light, currently we are sending a dichromatic light, for example, because we are sending two different wavelengths on the same grating normally. Two lines are observed in the first order spectrum and two lines are observed in the second order spectrum, which means both of these two wavelengths are giving us the first order spectrum and also the second order spectrum. We are definitely going to have central maxima for all diffusion grating, for all sorts of pairs and everything. So central maxima is a default presence. So in many cases, it's not even talked about because it is always there. Unless essentially required for other relevant calculation, the presence of central maxima is usually not discussed. So in this case, they are only talking about that two lines are observed for the first order spectrum and two lines are observed in the second order spectrum, corresponding to two wavelengths. We have that. State two differences between the first order spectrum and the second order spectrum. So what kind of difference are we going to see in between the first order spectrum and the second order spectrum? The first thing that I can think about, try to imagine that central maxima is the location where you will always have the brightest fringe, which we have seen for the double slit experiment, which is equally applicable for the what is it called, for the diffusion grating as well, which means central maxima will always be the brightest. The further you go away from central maxima on opposite sides, the brightness of those maximas is going to be dimmer. So obviously the first maximas are going to be brighter compared to the second maximas. This is the first thing. It goes without saying. So, and then they are asking us to give us two differences. So what is the other difference can we expect for us to have from these two wavelength differences? So these two wavelengths are going to give us what kind of figure? Should those first order maximas and second order maximas overlap onto each other, or should they be slightly different from each other? What do you think?
Sir, questionটা বুঝি নাই।
Well, they are saying that state two differences between the first order spectrum and the second order spectrum. The first thing that I said, that the first order spectrum would be more bright compared to the second order spectrum. That's what I said as one of the difference, which is the easier one. What can you think of a second difference? Try to think about a second difference without without me giving you any hint. State two difference between the first order spectrum and the second order spectrum. So what could possibly be the second difference?
I'm not sure, but phase difference কি একটা factor হতে পারে?
Well, Whenever we
Like,
talk about already the maximas are the point where the phase difference are in multiple of n into 360 degrees. So we have already said that we are trying to compare maximas. So for individual wavelengths, maximas are always gonna be their respective full multiple of 360 degree phase difference points for both of them. So they are both gonna
Okay, sir.
have 360 degree into n phase difference, but that's basically a similarity, not essentially a difference, don't you think?
so two lines are observed বলতে কি বুঝিয়েছে?
Oh, that's essentially what beautiful question. I was about to discuss about this part. I want you guys to understand this part very clearly. So I'm gonna try to get some simulation if I can. I hope Fate have something. Okay. I seem to have a lot of stuffs. Okay. So how does this work? This is the grating in place. Oh, beautiful. Oh, beautiful. So this is a diffusion grating, but in this figure, they haven't actually used a circular screen. Rather, they have used a flat screen, pretty much like that part for this animation. And we can actually change the wavelength. So have a look. If we increase the wavelength and decrease the wavelength, what is happening? This is very beautiful. Actually, we can do. Let's do a halfway point for both of them, so that whenever we're gonna squash and stuff, you can understand. Let's say, and over here. Okay, fine. Let's consider this scenario. So here we are sending a single point laser. This is the diffusion grating. Diffusion grating is this one. So grating is not here, so we're having a single dot. Laser is only hitting this place. This is a screen. This is actually a pretty good animation. I cannot show you two different wavelengths over here, but I can show you the change of the wavelengths. And what does that do? So d sin theta equals 10 lambda. Try to think about this equation. If you increase the lambda, your n is going to decrease, which means you're going to have fewer maximum order of range. So the wave is going to become spaced out. So I'm not going to change this information. So this is actually showing us that on the screen how far apart the bright fringes are. So we are having a central maxima over here. This is the central maxima. So we are having one dot over here. This is the second dot. So this is the first order maxima, second order maxima, second order maxima. In this scale, we don't have the third order maxima because you don't see that the third order maxima is just missing the screen. So that is happening. We apparently have a lot of stuffs over here.
Interesting.
This is beautiful. I should bookmark this. Okay. Okay. Bookmark. Now, take a look. If I now increase the wavelength a little bit, so if I now increase the wavelength a little bit, the wave pattern is spreading out. Do you see that? Now, increasing the wavelength means it's slowly becoming red. This is the most red, the biggest wavelength of visible spectrum. And if you decrease the wavelength, the pattern is becoming squashed. You see, more lines are entering from the side. And eventually, whenever we add the violet color or deep purple, deep blue, we have a huge number of spacing. So this is the beautiful part. So what I want you to understand, whenever we're gonna send onto this one, two different lights, one is gonna give us one interference pattern, and a slightly bigger interference pattern is going to be a slightly spaced out. So we're going to have two different set of first order maxima. So if I try to draw this over here, this might as well look like this. For example, let's say this is your diffusion grating. So here we're sending both the waves. This is your screen. The central maxima is central maxima, for both of them same. one wave is going to give you first order maxima over here. The second wave is another wave is going to give you first order maxima over here. They're going to be slightly different from each other because they have different lambdas. Now, what I want you to understand, or what I want you to decide, that from this formula, d sine theta equals to n lambda, which one is going to be the first order maxima for the 520 and which one is going to be for 525? Closer one which will be which one, and the further one will be which one? Are you getting my point? I'm asking you that this one belongs to which one? 520 or 525 nanometer? Sorry, 590 and 595. The closer one.
595.
595.
The closer one should belong to the higher wavelength, because what we have seen over here, that whenever we increase the wavelength, sorry, so whenever we increase the wavelength, the wave spaced up more, and when we decrease the wavelength, wave gets closer. So it means whenever lambda is high, theta is, sin theta is also high. Try to understand this thing. Consider that d is the same and n is also 1. So sin theta and lambda are proportional. So if your lambda is slightly bigger, the sin theta will also be bigger, which means this one should be 590, this one should be 595. And বুঝাচ্ছে কি বলতেছি? If you send two different light rays, this is what we're gonna get. And this is something that I've also shown you for the white light dispersion, white light diffraction rating as well. We have lens simulation here as well. Wow. Wow. I don't believe what we're seeing. What just happened? This resource is amazing. Damn. Kids, I'm pretty excited. You do understand why?
Yes, sir.
Yes, sir.
জিনিসটা আসলে অনেক সেই।
Wow. Okay. Lucky me. Acha, it actually just animation. It's not actually simulation. At least it's not appearing to be simulation. Interference, reflection, color, wave. Acha, jai ho. So the point that I'm trying to make is that these two things would make a certain angle between them, and the second order spectrum would also have a similar behavior. For example, if you're gonna have two different second order spectrum, 590 is gonna be closer, and 595 is gonna be even further. So the question says that we are seeing both the first order spectrum and the second order spectrum. What are the differences between them? The first difference, I said that any of these one will be brighter compared to any of this one, because the first order spectrum will always be brighter compared to the second order spectrum. Sorry, first order maxima will be brighter than the second order maxima. The other difference can be that the difference of angle between them would be bigger. I mean, this one would be smaller compared to this one. I can tell you this from the expression that I showed you, that n and sin theta, they have a reverse relationship. Or you can say that first order spectrum, first order maxima is produced at a smaller angle, and second order maxima are produced at a bigger angle. This is also a difference. That for any of the wavelengths, the first order maxima is produced at a smaller deflection angle from the central maxima, and second order maxima is produced at a bigger angle. So these are the two differences that I can think about. I actually covered three differences over here. Let's have a look at the mark scheme, what they are trying to tell us. বলুন, তোমাদের কি white light এর diffraction টা মনে আছে? Like what happened whenever we send white light through this thing?
Yes, sir.
আচ্ছা, আমরা তো এইমাত্র এটাই দেখলাম। এখানে লেন্স সিমুলেশন আছে, অপটিক্স ফর হিউম্যান আই। lens and chromatic aberration, lens reflection, spherical aberration, lens simulation for iPad, plane mirrors, dispersion of light, reflection, thin film interference, polarization of light. Wow. Damn. So this is the polarization. This is unpolarized light. This is the first polarizer, second polarizer. Acha. So if I now increase this one, and if I match it with this one, we have a bit of reduction, and that reduction is maintained. But if we now do like this, we have zero passing. Works. Beautiful. Waves are losing their amplitude as they are going through different double slit interference. Oh, wow. This is beautiful. Holy crap. So Zarif, you just asked me one question, that aren't the other phase differences important for us or not? What I want you to understand is that certain locations on the springs, on the screen is what we actually are. Okay, this is the pad difference. I can actually make this a bit smaller for easier observation maybe. Okay, so if I now slowly increase this, okay, I wanted to see a couple of points. Exactly at the central maxima, we have perfect merging. Have a look. The two ends of the green and the red waves, they're perfectly merging with each other. This is the point that we're interested about and we talk about. So the two dots are practically coming to the same point. And then there is a certain point where they're perfectly out of phase, which would be, I think, available somewhere over here. You see, in this case, the crests are merging with the troughs and the troughs are merging with the crests. This is the first minima or dark point. For all the points in between, we have some sort of merging, but these are not perfectly out of phase or not perfectly in phase. So that's why we do not talk about them. So we're going to have, in some places, we're going to have constructive. For example, in cases where we have, for example, in this case, I mean, whenever it with respect to the wave each other, the side of the wave that is on the positive side of the displacement and on the negative side of the displacement, if they're similar, we're going to have constructive interference. If they're opposite, we're going to have destructive interference. So we're going to have alternately both of them. So these are not very definite points. So we do not usually highlight these points very much, but there is a certain point where you can have perfect opposition. For example, a point like this. Here the pad difference is about, they are saying 4.11. Actually, we can try to get this with this one. So what is our wavelength? Wavelength is given as 6.9. No, let's give wavelength a convenient number. Let's say 4, or maybe 8 is a good number. 8, exactly 8. Can I give 8 exactly 8? I cannot give exactly 8. Oh, okay, exactly 8. So currently pad difference is 0. So we can have one thing, distorted interference whenever pad difference is 4, exactly 4. So I'm now observing this one and trying to change this one. Okay, keyboard helps a bit better increasing so that I don't. Okay, so this is the point where we have the first order minima, and then if we get exactly 8 again, we're gonna get the first maxima. You see, now they are merging up and getting slowly becoming similar, and at exactly 8 they will perfectly match. This is beautiful. This is divine. Wow. Do you see that they're actually matching up exactly perfectly on this edge?
Yes, sir.
Oh my God. These people deserve some very good recognitions. I mean, I'm gonna post this link to, I'm gonna try and post this link to many of my notes. Go there, look this up. So yeah, there's Is it gonna maintain? No, it's not gonna maintain because now the pad difference is different if we change the L. All right, so the point that from which I actually deviated from here was this question. So I would like to see the mark scheme for this question. This is question number 3. Question number 3 mark scheme. Let's have a look. It says that I would like to no, not this one. Okay, this is a bit more better for seeing. So it says that the lines are further apart in second order. So lines further apart in second order means that they are talking about that within this part, this angle. So this angle is more compared to this angle. So in the first order, they are spread apart. I mean, the angle between the two first order is smaller. Angle between the two second order is bigger. So lines in the second order are more farther apart from each other. That's one point. And then I say, or lines fainter in second order. Lines fainter in second order means less bright. You don't have to use the word fainter. It's a difficult word to remember for me at least. So you can write that lines are less bright. Allow any sensible difference, 1 each, maximum 2. If difference stated but without reference to the orders, maximum 1 mark. So let's have a look at the examiner's report. This is number C. Many candidates gave at least one relevant difference based on either the angles of diffraction or intensity. A surprisingly large number of answers ignored the fact that the question specified the two wavelengths involved. Consequently, answers referred to two different wavelengths, frequencies in our color. In others, there were vague mentions of angles without a clear indication as to which angle reference was being made. So if you only write that angle is bigger, you're not going to get mark. You have to specify in the second order the angle between the two bright fringes is bigger compared in the first order. So you have to specify that which are you referring to whenever you're writing your answer. That's what they are implying here. It's a good question. Good question. So we did solve number 5. I would like to talk about this question a little bit because I want all of you to understand. Take a very good look over here and tell me for this math, what should we use as the value of A, which is slit separation? What should be the slit separation for this question? Take a good look at the figure. What is the value of slit separation?
1.5 minus
1.4 millimeter.
Take a good look at the marked location for 1.5. How far is 1.5?
The 1.5 minus 0.10 হবে না?
That's what I'm asking you to guess. Take a good look. Slit separation means, the way I have taught you, is the distance from the center to center. In this case, what would be the distance from center to center? The two slits are identical.
So center to
1.5 ই তো হবে।
1.5 ই হবে।
Center to center 1.5 ই হবে না?
Yes sir.
এটা কি বুঝতেছো সবাই? বলবান?
Yes.
খেয়াল করো। এই কোশ্চেনে যতটুকু 1.5 দেওয়া আছে, because it is level from bottom to bottom, তার মানে center to center 1.5 ই হবে। But let me take this figure and do some possible changes, and I'd like to show you those things. No. I just want to select this. How do I select this? This one. Okay. So I'm going to do some changes in this figure. So bear with me. Let's keep it here. If we labeled this 1.5 distance, if it was labeled like that, now what should be your slit separation?
1.6 millimeters.
Zarif said correct, but do all of you understand?
Yes sir.
উপরেও 0.05 অ্যাড করতে হবে, সরি 0.05 অ্যাড করতে হবে, নিচেও 0.05 অ্যাড করতে হবে। So practically আমাদের এটার সাথে 0.10 অ্যাড করতে হবে। So this would be that thing. Okay, beautiful. I'm going to do one more change. না বুঝলে রেসপন্ড করো।
স্যার স্লিট সেপারেশন আর হচ্ছে ডিফ্রাকশন গ্রেডিং কনস্ট্যান্ট কি সেম ভ্যালু?
না, slit separation is applicable for only double slit experiments. Hypothetically speaking, not hypothetically, মানে হচ্ছে if you think for similarity, slit separation and diffraction grading constant are practically the similar thing for both of these constructs, but they are not applicable alternately for both experiments. For diffraction grading, we use the diffraction grading constant, where we do have a lot of holes, a lot of slits to allow much brighter light to pass through. Whereas for double slit experiment, we only have 2 slits. That's it. But in terms of comparison, they represent the similar thing from center to center. Yes. So I'm going to do one more change over here, and I would like you to respond about that. If this figure was labeled in this manner, now what should be the value of slit separation? This is marked up to halfway mark.
Sir, 1.5 plus 0.1/2.
Yes, that is 1.55. Now the slit separation should be, this much should be 1.55. Can everybody see this is 1.55? এখান থেকে এইটুক তার সাথে আবার ওই উপরের হাফটুকু অ্যাড করতে হবে, যে এইটুকু অ্যাড করতে হবে। সো এইটুকু অ্যাড করতে হলে এইটুকুর অর্ধেক অ্যাড করতে হবে। সো এই জিনিসটা ইম্পর্টেন্ট। সো কোশ্চেনে তোমাদের ডিফারেন্ট লোকেশনে লেবেল করা থাকতে পারে। টেক এ মাইনিউট অবজারভেশন অফ দ্য ফিগার and understand what you're trying to get out of that figure and do your calculations accordingly. These are the points where the kids in many cases lose mark. আচ্ছা, এটা গেল। এটা actually pretty simple একটা জিনিস ছিল, but I wanted to discuss this in detail because this is important. And then it says habi jabi এগুলি পারবা, at least পারার কথা। তোমাদেরকে আমি ওয়েভ আঁকার প্রসিডিউর তো দেখাইছিলাম না, যে পয়েন্ট প্লট করে কিভাবে ওয়েভ আঁকতে হয় আগে ক্লাসে। একটা ওয়েভের আঁকার কনস্ট্রাকশন দেখাইছিলাম, রাইট?
Yes, sir.
আচ্ছা, I'm going to discuss this one as well. Might as well copy this. I'll paste. No solution. Okay. I'll also need the quotient, so let's copy this quotient as well. So have a look at this quotient. We have this wave printed for us, and then it says a second wave x of the same frequency as the wave on wave W also passes point P. This wave has an intensity of half I, and the phase difference between the two waves is 60 degrees. So this is only saying that the phase difference is 60 degrees. It's not saying lagging or leading. So we don't have to be very cautious about on the right or on the left. On figure 5.1, sketch the variation with time t for the displacement y of the wave x. So first thing, you need to find out the amplitude. What should be the amplitude of the new wave? And then you need to shift every point for 60 degree phase difference. So I'm showing you one more time so that you can help yourselves easily whenever you're drawing. First, here have a look. For the given wave, how many divisions do you have for the amplitude? How many divisions do you have for the amplitude? Y-axis, how many divisions? This wave has amplitude in how many vertical smallest division?
786.
So 10 division.
I can see 10 divisions, but you should be able to see 10 divisions as well.
Yes, sir.
Okay, so the amplitude for this wave is 10 divisions. The second wave is going to have an intensity of half I. So we have to first calculate what should be the amplitude of that wave. So have a look at this one. What we know, I proportional to amplitude squared, or I can write amplitude squared should be proportional to I, or amplitude should be proportional to root over of I. The reason I'm taking this one, because I want to find out that when I converts to half I, so then A should change into root over of half A, because there is a root factor over here. Change of I will affect A in root over proportion. So 1 by root 2 করলে কত হয় দেখো, half কে root করলে কত হয়? 0.707 পাইছো সবাই
জি স্যার।
Yes, sir.
ঠিক আছে তার মানে আমাদের নতুন যে ওয়েভটা আমরা এখানে আঁকতে যাচ্ছি this new wave should have an amplitude of 0.70 with respect to 1 so এখানে ছিল 10 division for the given wave it was 10 division original wave so the new wave let's say this was for AW and our new wave which is supposed to be AX this is supposed to be 10 into 0.707 which is basically 7 division so we're gonna try to draw a new wave which should have a amplitude of 7 division. This is the first point. The second point is that we have to shift the shape of this wave for a respective angle value of 60 degree. Now comes the key information. You should remember this part. That lambda is relevant to time period is relevant to 360 degree. Which means if this is the relationship, then for 60 degree phase difference, you should have a shift by 1/6 of this value. Whether it's t by 6 or it is lambda by 6. I've written the whole expression because in this case we are showing the wave of a single wave with respect to time. So this is the time axis. So t by 6 means we now need to shift the entire graph by 1/6 of time period amount. Now have a look. Time period can be very easily calculated. You can see from here to here how many horizontal divisions represent the time period. Take a count. How many horizontal divisions represent time period?
20.
কত?
Yeah. Wait, sir. Sorry. 30.
I can see 30. Can everyone else see 30?
Yes, sir.
So if I just now go over here, the full time period is 30 divisions. So if I divide 30 by 6, I get 5, which means now I have to make the second wave to take a shift by 5 divisions in any direction, left or right, because leading or lagging is not mentioned. So now I'm going to try to start plotting these points, and I want every one of you to understand very clearly. First thing first I'm going to do, I'm going to just shift all the equilibrium point. So this point, let's say I'm going to shift to the right over here. This point I'm going to shift right over here because these points are easier for me to plot. So I'm going to first going for the easy options. And then this is one of the other points should be here. So this is easy for me to plot. Now I'm going to try to plot the vertices. So this new wave that I'm trying to draw should have a vertical amplitude of 7 divisions and should be shifted by 5 divisions. So have a look, this point over here, I'm giving a mark over here, but you shouldn't. This is exactly halfway over here. So after 5 divisions should be somewhere over here. Exactly the halfway for the next 5 divisions. This is 5 divisions. And 7 from the vertical, this is 5, 1 to 7. So this should be my one of the vertex. So do you understand how did I get this point? Shifting this crest by 5 divisions and giving an amplitude of 7 divisions. I'm going to do the same thing over here. I'm going to shift this point by 5 divisions right up over here and give it an amplitude of 7 divisions. So right up over here. And the same thing over here as well. So this is shifted by 5 divisions and given an amplitude of 7 divisions. Now you have a pretty big, beautiful wave, but the problem is that you need to have another point marked over here. So where should this mark be for 5 division? For the time being, disregard the position over here. You can very easily draw this after you complete the part that you've plotted. So a part to come put to pore dekhachi. Don't worry about that. So you're gonna try to join these points as smoothly that you can to make a smooth curve. Drawing on right pad is a nightmare for me. But some people make super sketches on right pads. These people are inhuman. So let's say I've completed this one. Now, to get a good idea that where this point on the 5 division left should be, it's very simple. You take a look over here that for my drawing, which is essentially not very perfect, but you can see that beyond 5 division, this is touching right over here, going through over here. So this can vary from person to person. This will vary from person to person, but what I'm asking you to replicate is that whatever you have drawn for your drawing, you replicate that thing reversely on the left side. So on the right side, for 5 horizontal division, the rise is up to 6 division. I did not plan this point, but this just happened. So on the left side, this should drop by 6 division. So this should be my point over here. So I'm simply going to draw my curve to about to pass through here. So something like that. Just replicating this thing on the left side and reversed. Do you understand how did I draw this one? এটা কি বুঝা গেছে? এটা কিভাবে করছি?
Yes, sir.
ঠিক আছে? This in my opinion gives you a much easier process to draw. Draw the intersection first and then copy this part and reverse it logically on the other side so that you can complete the whole graph. So this is the how the graph is going to look like. A better drawing would should have made it better. But as long as you may label those points that like the way I have drawn the points, examiner is mostly highly likely to give you full marks because they will know that you exactly knew what you are doing. So always prefer to plot those points because that way the shape variation or not a very good shape would still be a minor thing for the examiner to mark, because the examiner would know that you exactly knew how to plot this graph and you did your homework. You knew how to do this. So that's my recommendation. Okay, I'll conclude the class for today right here because it's about 7:36. Thank you very much. And we'll pick up more problems next class and you'll be receiving your worksheet bundles pretty soon. I'll let you know about that as well. And also, for those of you who are interested, please go to that link. I might as well actually share this link with you. Yes, I would love if you to have this link. আচ্ছা, আমি লিংকটা শেয়ার করে দিচ্ছি। I'm concluding the class over here. Thank you. Bye. Allah Hafiz.
Bye, sir.